Hi everybody, welcome back to Get Your Play Online. We're going to go ahead and give everyone a few seconds to let the live get going, and then we're going to go ahead and dive right on in to another week of our awesome summer programming here at Get Your Play Online. So for those of you that might be your first video with me, my name is Morgan, and I like to do science activities that use items that you probably have at home. Anytime we can, we like to use recycled materials, and we like to learn all about science. So if you're new to Get Your Play Online, every week of the summer we've done an awesome new theme. This theme of the week is going to be underwater and ocean and all of that kind of really awesome and interesting things. And today we're going to learn all about buoyancy and how animals float in water. Because sometimes if humans go into water, they don't necessarily float, we have to swim. But animals like whales and dolphins and seals can just kind of float there, and you don't see them swimming like humans. So we're going to learn today how that works and why that works, and we're going to do a really fun craft to help us learn all about it. So I like to start off my segments whenever I can with a fun joke, and I found one that meets our ocean theme really well, and I think it's really funny, so I'm going to go ahead and share that with you. How do oceans say goodbye? Now, if you ever have an answer to this joke, you can always put it down in the comment. Let us know that you're watching and that you have an idea. So the answer of how do oceans say goodbye is they wave. I know, kind of a corny joke, but I think it's pretty funny. I think corny jokes are funny and fun. So to start off my segments, I always like to share my supply list and then what my hypotheses are. If you don't know what a hypothesis is, it's basically a scientific guess. So today what we're going to do is we're going to mix different materials such as salt, baking soda, cornstarch, sugar into different amounts of water, and we're going to see which items float with what materials. So if you've ever been to an ocean, you know ocean water is very, very salty, and I think that might have something to do with why animals can float. So today we're going to go ahead and test that, and so I like to share a few hypotheses. So when I thought about this project, I said, I wonder. If you ever find yourself thinking that while you're doing science, that's probably a hypothesis. So we're going to go ahead and share our supply list and then our hypotheses, and then we're going to dive right on into our activity. So let me grab my supply list. So it looks a little bit long today. The best part about this activity is you can use pretty much anything you have on hand. Some of the supplies I went out and got from some board games we had. I had just some loose change that we're going to try to use, and then some really simple kitchen items such as salt. So let's look at our list. So we're going to need some small plastic items. I'll go ahead and share with you in just a second what items I chose. You're going to need clear cups. You don't want to use a cup that you can't see through, or else you won't be able to see if your item is floating or sinking. You're going to need water, salt, sugar, baking soda, a tablespoon measurer, a spoon for stirring, and then I brought some extras today that I want to test out, and those are some coins. So I have pennies and dimes, and I have some cornstarch, because I'm wondering if cornstarch, since it's so dense, may help our materials to stay up. So let's go ahead and take a look at what all of these supplies look like. So our small plastic items that I found, I actually got out of a board game. So they're just small and plastic, and they come in a bunch of different colors. So I have 5 of those, since we're going to test 5 different things today. Next, clear cups. I like to use these small clear cups because I can see right through them, and they're nice and clear. So I have 5 of those all ready for our activity. Next, we have some water. I put mine into a pitcher because it's going to be very important that we pour the same amount of water into every cup, and so a pitcher will help me pour that a little bit easier. Put that back over here. Next, we have some salt. I'm just going to use some regular old iodized salt. You probably have some of that in your kitchen. Next is sugar. I have our big sugar container right here. So we have our sugar ready. Baking soda. You may use this to bake or cook. So I have some of that. Next is my tablespoon. Where did my tablespoon run off to? We'll go ahead and find that in just a second. And then I am going to use a regular old kitchen spoon. It's important that you make sure you wash this before somebody else uses it, because we are going to be stirring things like salt and baking soda, which may not taste very good if you were to use this spoon before you cleaned it. Next, we have coins. Like I said, I've got some pennies and I have some dimes, so I thought it'd be interesting to test these since they're made of different kinds of metals and they're different weights to see if that may sink or float. And then lastly is some cornstarch. So we have that. Let me see where my tablespoon ran off to. Ah, there we go. I was hiding behind my computer. So then it's just a tablespoon measurer. Just like our spoon, you're gonna wanna make sure you wash this since we are going to measure lots of different things with it. Okay, so now that we have our supply list, I think we should cover what my hypotheses are for this activity. Now remember, it's okay to be wrong. If you've watched my other videos, my hypotheses aren't right all the time. A lot of the times, they're incorrect, and that's okay. The best part about a hypothesis is that it allows you to make changes to what you originally thought, so you can learn more and test new things. So, I have 3 hypotheses today. We're going to cover them throughout the video. My first one is that I think mixing salt with water will let the plastic items float. I think that because I know ocean animals have to be able to float, and I'm thinking it's because they're in salt water. The next one is that I think all of the coins will sink. I think they're just too heavy and too dense. So dense means very solid, and that it's made of a more solid material. So coins are very dense because they're made of metal. And lastly, I think the sugar will let the plastic float too. So I think we should go ahead and start testing these. All right, so to test these, I'm going to go ahead and move you all so you can see my workstation a little bit better. I'm going to move you down just like that. So you won't be able to see my face, but you'll be able to hear me talking. So I'm going to put out 5 plastic cups. So we have 1, 2, 3, 4, and 5. I have an extra one just in case. So let's make sure everyone can see these. So when you're doing science, it's important to have something called a control. And in control is going to be this cup right here. So this is going to be our control cup, and our control is an item that you don't do anything to. So for our example today, our control is just going to have water. We're not going to mix anything into it. So our control cup will just be water. Next, baking soda. So it's going to be really important that we remember which one we put in which cup, since they're all going to look pretty similar once we mix them together. So I think for me to remember, I'm going to put it behind the item so that I can always remember what we put in there. So we have baking soda. The next one I think we should do is salt. After that, let's do cornstarch. Cornstarch will be in cup number 4. And then lastly, we're going to do our sugar. So we have 5 cups and 4 items we're testing, and this is going to be our control. It's important to have a control so that we know how the individual item is influencing our water. So by not putting anything in here, we have just regular old water to compare to the results that we find with the rest of our materials. So what we're going to do is I'm going to slide these over just so I have a little bit of extra room to pour our water. So it's going to be very important that we add the same amount of water and the same amount of our materials to our water, once again, to be able to test how the material reacts versus testing different volumes of water and our material. So what we're going to do is we're going to start pouring water into the cups. And what I'm going to try to do is make sure that each cup has the same amount. It doesn't have to be exactly the same, but we want it to be as close as possible. So we're going to go ahead and keep pouring. That looks about equal. Pour in a cup number 4. That looks good to me. And one more. Alright, let me take a look. Those all look pretty equal to me. I might add a little bit more water to this one here. A little bit more water to this one here. Perfect. Go ahead and put my water off to the side. Now, so all of our cups have the same amount of water in them, which is great. Now we're going to put the same amount of material in each one except our control. Our control is not going to have anything in it. I think to help myself remember that, I'm going to put a sticky note over the top of our control cup so that I remember not to put anything in it. Alright, so now we know this is our control cup. So what we're going to do is we're going to use our tablespoon measurer, and we're going to put 2 tablespoons of all of our materials in our water. So first off is our baking soda. Open that up. Put my tablespoon in. I'm going to get 2 tablespoons of baking soda. Alright, so we have our first one. And you're just going to pour that into the cup, and you're going to notice the water's going to get a little cloudy, and that's totally normal. That's what you expect to see. Okay. And number 2. So pour that in. And now, I'm going to put that in the front, actually. It'll give me a little bit more space to work, but I'll remember which one is which. I'm going to take our spoon, and I'm going to stir. So it's important that you stir the material into the water. or else it'll just sit down at the bottom and it won't help our experiment. So we're going to mix that, mix, 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 mix. Perfect. All right, we're going to let that sit for a second. And actually what we can do is I'll grab a pen right here. And just like we put a sticky note over here, I'm going to write what we put in it and put it over the top for right now. So we have baking. This is baking soda. Perfect. So go ahead and put that over the top so I can remember which one we put in there. Next, let's go ahead and put our salt. So we're going to need 2 tablespoons of salt. So we have 1 tablespoon. Oh, looks like I might have to go get some more salt. Almost out. So we have 1 tablespoon. Yep, looks like I ran out of salt. Not a problem. I'm going to go and grab another thing of salt. I'll be right back. Alright, I got another container of salt. I'm just going to go ahead and open that so I can use that in our experiment. So as you can see, it looks like our baking soda is starting to mix well into the water. And you can tell that because there's not a lot of it clumped down at the bottom, which is what you want to see. So if you're doing this experiment at home and you notice a lot of clumping of your material at the bottom, you want to mix it more. Because if it's sitting down at the bottom, it's not mixed into the water well enough to help you learn about how it's influencing the water. All right, now I got that open. That took a little bit of time. That's okay. I'm going to go ahead and fill that all the way up to the top. I'll put a little extra since my last one wasn't very full. All right, perfect. Put my salt off to the side. It almost smells like the ocean. I can smell the salts. I'm going to mix that up. So you can see before we mix it, there's a little bit more of that material down at the bottom. You can see it next to my spoon. See right there? So you're going to want to mix that until all that clumpiness goes away. Mix, 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 mix. And it may take a little bit of time for all of that to mix in there, and that's totally fine, not a problem. The more mixed the material is, the better off your experiment will be. Go ahead and keep on mixing, keep on mixing. Before we add any of our ingredients, we'll go ahead and do another stir. So I'm going to use my sticky note and write salt on top of that. And I'll go ahead and take that out. And while my spoon is over here, I'm going to give the baking soda another stir. Looks like some of it is still at the bottom. Mixing. All right. Like I said, we'll give that another mix right before we start our experiment. So I'm also noticing how close these look to each other, so I'm really glad that I'm putting the notes on top of it so I can remember which one's which. All right. Next, I think I'm going to add the sugar. So I have my sugar in this big container, so I'm just going to carefully reach down in there and get 2 tablespoons. You can see it adding into that water. 1 and 2. It almost looks like the sugar went right down to the bottom, and it doesn't look like it's mixing up at all. That's kind of interesting. I wonder how that will impact our experiment. See? Take a look. See, the water's clear, and all that sugar is sitting right down at the bottom of our cup. So, I think we're going to need a good stir on this one. Stir, 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 stir. This experiment is also a good way of testing how long it takes for different materials to break down in water. So right now we're testing the water solubility of an item. So solubility refers to how quickly a different material will break down in water. So it looks like even though the sugar went right down to the bottom, it's pretty soluble and it disintegrated very quickly. And our last item we're going to put in here is our cornstarch. So we have our cornstarch here. Go ahead and open this up. We'll add 1 cup, or 1 tablespoon, not a cup, silly, and 2 cups. So you can see it almost looks like it's just sitting right on the top like an iceberg. See how it's sitting right on the top there? And it's not mixing in. I think we're going to have to stir this one pretty well. So let's try to break that up. This one's very hard to stir. You can see how it's very clumpy and runny. This is actually another kind of craft that you can make. If you mix equal parts of cornstarch and water together, you can actually make something called oobleck. It's lots of fun. I'd recommend it. It's not what we're going to focus on today. I'm just going to go ahead and try to carefully stir this without spilling it. Stir. It almost looks like milk. But even though it looks like milk, please remember not to drink any of these materials. Even though they are things that you would cook or drink, or cook or bake with, you don't want to drink them. That can make you sick, and it would probably taste very bad. So make sure you always have a grown-up's permission before you do any of our Get Your Play Online activities, just so they know what kind of activities you are doing. All right, so let's write sugar. And we have our cornstarch. Okay, perfect. So we have our 4 different materials. We have our baking soda, our salt, our sugar, and our cornstarch. And remember, this one's our control. So this one has absolutely nothing in it. It's just water. This one's our baking soda, which looks like it needs a little bit more of a stir. So we can go ahead and give that another stir. Then our salt. Our salt looks like it's mixed in very well. There's very little salt at the bottom, so that's awesome. Now it's interesting, our sugar one looks just as clear as our control. So if you see, you can't even tell which one's which. This is the one with the sugar in it. This has nothing in it, but they look almost the same. I wonder how that's going to influence my hypothesis. And lastly is our cornstarch, and our cornstarch looks very different in comparison to the rest of our materials. So what I think I'm going to do is I'm going to give our baking soda one more final stir, and then we can go ahead and start testing our different materials. Another important reason that you want to stir it until everything is mixed in is that it will make the water clear, which may allow you to be able to see the items you drop in a little bit better. So it might be hard for us to see any items in the cornstarch and maybe even our baking soda today, since it's a little bit more opaque and not clear. So I'm going to mix, mix, mix. Mix the other way. All right. I think that's about as mixed as it's going to get. So I'm going to take our sticky notes off and I'm going to put it right there in front of me so I can remember. You may not be able to see it, but I can always remind you which one we're working with. And our control. All right, so I think I want to start off our experiment with our plastic items. So remember, these I think came from just a regular board game. They're thin, they're plastic, and they're very light. So my first hypothesis is that the salt will let these float and that the sugar will let these float. So I think first off we're going to go ahead and test it in our regular control. So I might put this up here. We might balance our cup right up on our salt container. It's going to let everyone see what we're doing a little bit better. Okay. So I'm going to put a green one in the regular control. So remember, the control has no other materials in it. All right, we can do this and I can hold it. Everyone see? So we're going to hold it up and we're going to drop our item in. I think this is going to sink. So it did. It sunk slowly down to the bottom of the cup. All right. Next is our baking soda. I think I'm going to use a red one for this. So here's our baking soda. I'm going to carefully place our item in the baking soda. And that floated. So see, it's hanging out right on the surface of the water and it's not sinking. So it looks like baking soda allows things to be buoyant. So remember, Buoyancy is what allows our sea animals to float, and so that's what we're trying to replicate here with our experiment. So it looks like water doesn't, without anything in it, doesn't really help anything become buoyant, but baking soda does. So let's go ahead and give salt a try. Same thing, I'll hold it up so you can see. I'm going to put our item in there. And just like I expected, my hypothesis was that the plastic will float inside the salt water, and it looks like I was right. So I'm wondering if that does have anything to do with why those animals are able to float so well. Next is sugar. I'm going to use a yellow item for this, and I'm going to carefully put that in there. And it looks like it's floating in the sugar as well. That's pretty cool. I wonder why the ocean isn't made of sugar water. I think that would taste a little bit better if you ever got it in your mouth while you're swimming. So I don't know about you, but that's happened to me before, and it does not taste good. It is so salty. Next is going to be our cornstarch, and I saved our purple one because I'm thinking the purple one might be easiest to see inside of our cornstarch. So let's go ahead and put it inside. Oh, now you can't see. You can see the surface of the container, and it floated right down to the bottom. So it looks like cornstarch doesn't help any items to become buoyant. But if we go ahead and look here, neither does the water. So our item is right down at the bottom. But our baking soda, it's still floating at the top. Our salt, it's still floating perfectly at the top. And so is our sugar. So that's pretty interesting. So it looks like 3 of our 5 tests increase the buoyancy of our object. So the object down here is the same as the object in all the other cups. So it means that it's not the object that's making it float, but it's what we added to the cups. So that's pretty interesting. Next, I think I want to go ahead and try a dime. So the dime is the smallest coin, so I think it's the most likely to float if any of them are going to float. So dimes are actually made up of mostly copper with just a little bit of nickel in it. So it's different kinds of metal, so I think they might sink still just because it's metal, and metal is a lot more dense than plastic. Plastic has a little bit more air in it, and air helps things to float. So I think we're going to go ahead and give that a try. So first, we're going to put our nickel in our water. 3, 2, 1. Oh, that sunk right to the bottom. Didn't float at all. See, you can see it down there with our chip. Now, baking soda was buoyant for the plastic, but is it going to be buoyant for our dime? Let's go ahead and give it a try. 3, 2, 1. Nope, it went right to the bottom too. Now our salt water. All right, let's give this one a try. 3, 2, 1. Oh, it doesn't look like our metal is going to be buoyant in any of our materials, but let's give sugar a try. 3, 2, and 1. Sunk right to the bottom. Last but not least is our cornstarch. 3, 2, and 1. Sunk right to the bottom too. So it looks like none of our materials that we added to the water are going to increase the buoyancy enough to allow something as dense as a coin to float. But I still think we should go ahead and try our pennies since we have them here and ready to try. You never know, since a penny is made of a different material than a dime. So like I said, dimes are made up of about 90% copper and about 10% or so nickel, but pennies are made almost all of zinc. So zinc is a different kind of metal, and it's coated with copper. So dimes are almost all copper, where pennies only have a little bit of copper. I wonder if the metals influence their ability to be buoyant or not. So let's go ahead and try. Here's our regular water. Remember, this is our control cup. 3, 2, 1. Sunk right to the bottom. Baking soda. 3, 2, 1. So that sunk right to the bottom, but it looked like it took a little bit more time than it did when we put it right into the regular water, so our control. So maybe the baking soda did help it fall a little bit slower, but it still didn't allow it to float. So let's try our salt water. 3, 2, 1. Same thing, it went right down to the bottom. Didn't float at all. Next is our sugar water. 3, 2, and 1. Nope, didn't float. And last but not least is our cornstarch, which I know really looks like milk, but I promise you it's not. 3, 2, and 1. Sunk right down to the bottom. So, it looks like if you want something to float, you need to add sugar, salt, or baking soda to it, which is very interesting. So, I think the conclusion of our experiment is that baking soda, salt, and sugar increase the buoyancy of water, allowing things to float, whereas regular water and cornstarch do not. So let's go ahead and take a look at my hypotheses and see how I did. So, hypothesis number 1, the salt will let the plastic float. I was correct. The plastic is still floating at the top of the cup, so that's cool. Number 2, the coins will sink. That was right too, so I have 2 correct hypotheses today. In every single one of our cups, every single one of our materials, and in both the coins, every single one sunk. And number 3 is that the sugar will let the plastic float. And it looks like I was correct there too. So today I had 3 correct hypotheses, which doesn't normally happen. Normally I have a couple hypotheses that aren't right, and that's totally okay. It's part about being a scientist. Scientists don't get things right every single time, and that's okay. Some of your best learning may come from mistakes. You get everything right all the time, you don't have an opportunity to try different things and learn new techniques, but when you do get things wrong, you're able to go back and make changes, and those changes are what help you be a better scientist. So everyone, I want to thank you all so much for coming to another awesome week of science. We have one more week of our summer programming next week, so we invite you all to come on back and check that out with us. It's another really great theme, and we're just so happy that you're all coming and checking out our material, and I'm so happy that you all came and joined me while we learned about buoyancy and what makes sea animals float. So I hope everyone has a great rest of your day. Bye!